voice accent learning using recurrent neural networks and spectrograms. The goal is to be able to learn the difference between the American accent and the British accent so that the difference can be used to partially alter the voice of someone with the American accent with the British one. The model uses a many-to-many two-layer LSTM network with two fully connected networks at each time slice. Inputs are spectrogram images of computer-synthesized speech in American accent and British accent. Results show that the model works when trained with input data consisting of one word at a time. Wave sound files were converted to spectrogram images and cropped to 150 by 50. Values are normalized to 0 and 1 and uses features in this time series dataset, which is appropriate for training sequence RNN models. Words are mined from IMDb reviews with more frequently words repeated up to 5 times. Here's the model at each vertical slice, which is a time step in the spectrogram. It's first sent to an LSTM layer with 1024 hidden units, and then that's concatenated back with the input and sent to a second LSTM layer of the same configuration, and then both of the LSTM layer outputs along with the input are all concatenated together and sent to a fully connected layer of size 2048, and then that is reduced to size 50 in another fully connected layer, which is the prediction of that slice of the image. The loss function is mean absolute error. Optimizer is RMS prop. 40,000 pairs of spectrograms were used in training and 5,000 for validation. The final model was trained for over 400 epochs, over 40 hours. Here are the graphs of the training. We stopped where validation started flattening. Here are some sample predictions using the final model tests. The two-layer recurrent neural network setup is usually used as the encoder and decoder layers in language translation. It did moderately well for the translation of spectrograms and two accents. The results are due to the powerful abilities of RNNs to remember sequences. Backprop during training were helped with skip connections. 10H did better than Really. Dropouts were helpful, and training takes a long time. For the future, we'll like to train the full spectrogram of 300 by 257, use more training samples, use greater vocabulary, additional voice, and more LSTM units. Thank you.